Hey guys, today we're going to be talking about function arithmetic. So just function math pretty much. Before we get into the video, make sure you subscribe so you can find out more and learn some more math. And I'll be posting videos daily for at least a week or two so we can catch up on some videos. So let's get right into it. So as it sounds, you can do math with functions, and everything we can do with regular numbers, like addition and subtraction, we can also do with functions. So if you had two functions, let's say f plus g of x, this is distributed out to be f of x plus g of x. Let's go over all of them. F of x plus g of x. This is just distributive. Let's do minus. So f minus g of x is equal to, as you would expect, f of x minus g of x. And the next one would be fg of x is equal to f of x times g of x. So this is very useful to know because you can take two different functions, compose them together just by doing this. So instead of having to insert the number first, you can actually put them together and get the exact same solution. We'll go over some examples in a second by what I mean. So f over g of x is equal to f of x over g of x. So these are the four function math that you can do. So function math, call it function math. So let's do some examples. This is going to be a quick video because there's not a lot to this, but it's important to know that you can do it. I would memorize all of these and how it gets distributed out because later you'll get into function compositions, which is functions within functions, and you should be able to do all of this math. So let's do an example. Let's say we had some, let me change colors just for fun. Let's do f of x is equal to 6x squared minus 2x, and we had some g of x is equal to 3 minus 1 over x. And let's say we want to solve this right here. F of g of x is equal to f of g of 2. So we want to figure out what is the function f times function g evaluated at 2. Evaluated at 2. So how can we go about doing this? Well, all we have to do is sub those two in and then multiply them together. So we know that this is actually equal to f of 2 times g of 2. So let's start by evaluating these now. And let's start with f of x. So f of 2 is equal to 6 times 2 squared minus 2 times 2. If you simplify this, you just get 24 minus 4, 20. And we have g of x is equal to 3 minus 1 over x, which is 3 minus a half, which is then a equivalent to, I had 5 over 2, 5 over 2, and then all you have to do now is to find f of gx, all you have to do is multiply 20 times 5 over 2, which is 100 divided by 2, 50. And so in this way, you don't have to multiply out the long thing. So the other option would have been to actually multiply out the function instead of evaluating it first, which would have been more complex and would have taken more time for you to do. So let's do another example. Let me scroll down here. Let's do another example. So let's do let me write f of x is equal to 6x squared minus 2x. We'll leave these as functions that we're going to work with. And g of x is equal to 3 minus 1 over x. And so the question is, let's find the domain. Find the domain of f minus g. Find the domain of f minus g. So how do we go about doing this? So first, we know f minus g of x is equal to f of x minus g of x. And now we can substitute those functions in. 6x squared minus 2x bracket minus 3 minus 1 over x. And if we simplify this down, we get 6x squared minus 2x minus 3 plus 1 over x. And so let's find the domain. So what are the two things we always check for? One is negatives under radicals, and the second one is divide by 0. This is the two things I usually always check for. So let's see. Are there negatives under radicals? There's no negatives under radicals. Is there a possible divide by 0? Yes, there is. So this right here cannot be 0. This denominator right here can't be equal to 0. So we do what we usually do is we know this cannot equal to 0, but it works for every other value less than or greater. So if we write this in set notation, the domain is simply negative infinity to 0 and 0 to infinity. And so that's just some set math. Not set math. This is just pretty much some function math that you'll be exploring later, and this will become super useful when we start doing composition of functions, and it's just a good thing to know overall. That's it for now. I'll catch you guys in the next video. Make sure you like this video if you liked it, and make sure you subscribe for more videos coming out daily for a whole week. I'll catch you guys in the next one. Bye.